Thank you for joining us for today's webinar, Selecting and Specifying Ceramic Tile with ANSI and ISO Standards. Just a little bit of housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the box in the corner of your screen, and we'll answer them at the end of today's presentation, time permitting, or via email after. You can always email questions at any time to mapeidigital@mapei.com. Now, without further delay, I'd like to introduce today's speaker, Jim Whitfield. Jim is MAPEI's Technical Services Director and has been active on many industry committees over the years. He's currently serving as the President of the Materials and Methods Standards Association. He also belongs to the National Tile Contractors Association's Technical Committee and the Tile Council of North America's Handbook Committee. In addition, Jim is a voting member of the ANSI ASC A108 committee. In 2001, he received the Fellowship of the Construction Specifications Institute, thanks to his contributions to education in the construction industry. Jim, the floor is yours.
Thank you, Jen. Welcome. I appreciate you taking time out of your day to join us. Today, we're going to talk about ANSI and the ISO standards. For some learning objectives, this session will provide a perspective on industry standards, including new as well as new mortar classifications. We'll discuss ISO designations and the new ANSI mortar designations for non-sag, fast setting, extended open time, and the new large and heavy tile mortar designation, and how it'll benefit the design professional as well as tile contractor out in the field. We'll discuss recent changes to the ANSI standards in general, things we've recently added. And this presentation will provide the contractor with practical knowledge on the use of the standards as a project tool. First, let's talk about TCNA. TCNA handbook, in the very front of the book, it talks about using the TCNA handbook for specification writing. I know this is difficult to read. It's a lot of information on a single page, but hopefully this next page will help you a little bit more. Think of TCNA as kind of a guideline, if you might. The TCNA handbook's not a specification. It's really a reference that includes CAD details, et cetera, on installation methods. But what's highlighted in this first paragraph of the TCNA handbook for the use of the handbook as a specification is use the American National Standards Institute, ANSI standards for developing specifications. And that specifications should conform to applicable building codes, ordinances, trade practices, and standards and climatic conditions. So just wanted to kind of get that out of the way. TCNA handbook by itself is not alone. It really references ANSI. And so as we get into a method, and if you might, this is a typical method in the TCNA handbook, I just wanted to point out, and let me get a cool little pointer that they've got, that in here you'll notice that the materials all are specified by ANSI standards. And where applicable, you'll also notice ISO standards as well. So same thing true of the grouts, the membranes. Uncoupling is still working on a standard, and porcelain tile, the different types of mortars that should be used for it. You also notice that they've got installation guidelines. So for the tile, as well as glass tile, cementitious grouts, crack isolation membrane, uncoupling, and movement joints. So again, they're all kind of interconnected. You'll notice under notes, they talk about crack isolation when used 11812, et cetera, et cetera. So they are heavily connected together, and that's important. So they're two different documents that work extremely well together in harmony in trying to help a design professional and or tile contractor put together the best specifications they can for a project. Now, as I was mentioned in the beginning, I am very actively involved in a lot of the different committees, from TCNA to ANSI to you name it. And So those documents, if you might, are put together by open consensus or industry consensus. What does that mean? Well, that means we kind of throw a bunch of people in a room and we just kind of work it out, or fight it out, if you might, until we agree on something. I can't think of a better example of this than if you've noticed the gauge porcelain tile standard is the gauge porcelain tile and gauge porcelain tile panels / slabs. So the technical tile committee at ANSI trying to decide on the name for gauge porcelain tile, or thin tile is what we used to call it. And in the room, many of the manufacturers like the word gauge porcelain tile panels. Others like the term gauge porcelain tile slabs. So you've now got a gauge porcelain tile standard, material standard, as well as gauge porcelain tile panels / slabs. That is consensus. We came to an agreement on what it should be called. So we worked very, very hard in trying to get agreement throughout the committee. And you're talking about 64 plus attendees or members of the committees trying to agree on documents, what they should say. It really takes a lot of work to work as a large group from different entities and really come up with a good agreement. Some committees are better at that than others. We passed the ANSI standard for the material for tile, as well as installation for gauge porcelain tile interior with thin-set mortar in about 18 to 24 months. So that was probably one of the best standards I've ever seen go through. One we've been working on for probably close to 10 years now is uncoupling membranes, and that's still moving along at a swift pace, but still not completed after, as I said, close to 10 years. But I think we'll get that wrapped up soon. So it all depends on the complexity of it, as well as in the case of gauge porcelain tile, I really think what really pushed that along was a need to get it done. In other words, everybody on the committee recognized the importance of getting a gauge porcelain tile standard out there for the material, as well as a gauge porcelain tile installation standard. So we worked very hard as a group to try and make sure that went through as quick as possible. All right, ANSI. It used to be updated every 5 years. Now we can do it electronically yearly, really. We do it quite frequently, and the overall heavy review, if you might, is about every 5 years still, but it's updated every single year whenever something important happens. A good example is the H designation for medium bed mortars or large and heavy tile mortars. So as I mentioned, it's revised about every 5 years. It is referred to in the TCNA handbook methods, as I showed you in the beginning of the program. I kind of like to think of the TCNA handbook as a set of plans on a project, and this being the specifications for the project. In other words, all the details that you need, no pretty pictures, just a lot of the details that you need in order to accomplish that project, establishing kind of the quality of the products that are going to be used, right? And that's what we do with a project in a commercial atmosphere. We've got a set of drawings. They pretty much give you the quantitative requirements that are needed. This gives you the quality of the material that is needed. It includes specifications. It includes environmental conditions, when the product's to be used, etc., and coverages that are required. How much coverage is required for the thin-set mortar, if you might, for use between a tile and the substrate. There's a variety of ANSI booklets in the tile industry. A108 is probably the one that's most commonly known, and that is for the installation standards. A118 and 136 is for material specifications. A137.1 is a specification for ceramic tile. A137.2 is for glass tile, a product for the product itself. A137.3 is a standard for gauge porcelain tile and gauge porcelain tile panels / slabs. Last is A138.1, which is the sustainability ANSI document for ceramic tile, glass tiles, and installation materials. All very important in our tile industry. What we hear the most about is A108 and 118. Let's talk a little bit more about ANSI standards and some that are really being heavily worked on at this time. One would be ready to use or pre-mixed grouts. A good example of that is our Flex Color CQ. You open the bucket, you use it, etc. It's kind of a new thing within the last 6 to 8 years. So we're working on a standard for that. Again, I think that's progressed very, very well in the last couple of years. The standard's actually being written. Round robin testing, I believe, is completed. So it's just a matter of analyzing all the results. Uncoupling membranes is one I mentioned earlier that's being worked on. There's a product standard for SLU or self-leveling underlayments. Under review is the crack isolation standard. One that's being considered is a standard for industrial epoxy grouts. These are ones used heavily in commercial kitchens and so on. They are a little bit different than the everyday epoxies that you're used to 10 years ago. They're not your father's epoxies, if you might. These really hold up well to heavy chemical situations and food fats, if you might. Tile deformation. A machine that'll actually measure the tile, and if it gets wet, if it expands at all, if it moves, if it is not stable. We have a standard just for the ISO block texture, and that's being worked on, by the way. And it's been a 1.5-year project as well, and a lot of testing, a lot of round robin testing. So what happens with these products is when we decide that we think that there's a standard that should be developed, first thing we have to do is look at what's in place. And let me use uncoupling membrane as an example, because I think this one kind of got off to maybe not a bad start, but not maybe the best start it could have. And that's because initially they felt like the uncoupling membrane really should be similar to a crack isolation membrane, but it had better features. So if it just met the crack isolation membrane standard for standard or high performance for 1/8 of an inch or more of cracking, we really wouldn't need an uncoupling membrane standard. We already have a crack isolation standard in, and we might even make that another category within it, but that's not what happened. We ended up looking at the benefits of an uncoupling membrane and said it can do things that a typical crack isolation one can't do. A great example of that is vapor. It handles vapor very, very well. So we've got vapor coming up through a slab may be on grade, moisture in the ground, it wants to come up through the concrete slab. In the case of a bonded membrane, like a liquid membrane, it applies pressure to the bottom side, eventually could possibly even lift that membrane up. In the case of uncoupling, because of the void between the fleece and the bottom of the membrane, which would really be in this area, it really can't build up that type of pressure. So it performs extremely well for vapor. It has some other benefits as well, but really that became a big part of the testing on this product is how do we show that this works versus a crack isolation membrane that doesn't. So in order to create a new standard, we have to show why it's different than the ones that are currently in the standards. I hope that makes sense. In the case of a flex mortar, a single component grout, like our Flex Color CQ or some of the others out there, Fusion and I'm sorry, I can't think of the other competitors off the top of my head. But anyway, we just have to show why that's a little bit different than cement. In typical cement grouts, what we do is we create a 2x2 cube and use it for compression and for compressive testing and other things. In the case of a ready-to-use grout, it's more flexible or soft than that. And to fill up a cube would work, but you wouldn't get anything close to what you would anticipate out of cement grouts. So the type of compression test that they're using is very, very different than what we use in the tile industry today for cement grouts. Very different, and that'll definitely set it apart. Other standards that are under review right now, we've got gauge porcelain tile exterior. That's virtually done. It's going out to vote. We've actually answered all the negatives for it recently. So a great example of a committee really working hard to get a standard through as well, and well managed by Noah Chitty. The exterior installation standard, before it goes out to vote, it was sent out to members and asked for any comments, any negatives up front. So then the committee tried to address all the negatives. Those were recently addressed back to the membership. And so when it goes out to vote, by theory, it should pass very easily because we've already addressed the negatives. ANSI A108.5 for basic dry set mortar and latex modified thin set. That standard's under revision right now. The coverage requirements have been discussed nonstop for the last 5 years, I think, and still are a consideration. And there's also a self-leveling underlayment installation standard out there for vote. If not done, very, very close to being completed. Some recent changes to ANSI is the A10819 gauge porcelain tile installation standard. Again, that's for interiors only with a thin set mortar. ANSI A137.3 gauge porcelain tile as a product. In other words, the standard for manufacturing the product, the types of strengths it should have, where it could be used, etc. The H designation was added to mortars for large and heavy tile mortars. I'll get into this in a little bit more detail. All the designations for ANSI mortars were added in 2012. In addition to that, in 2012, we came out with a new standard for mortars, and that is the improved modified dry set cement mortar. So we'll get into this in a little bit more detail as well, but a premium mortar, if you might. All right, let's talk about the gauge porcelain tile and gauge porcelain tile panels / slabs standards. ANSI A137.3 is the tile standard for gauge porcelain tile. ANSI A10819 is the installation standard for interiors with a thin set mortar. Why gauged? The technical tile committee felt like it made sense that this is a measured material, and the easiest way to refer to it would be gauge, much like we do barbed wire or wire or anything like that. 14 gauge wire, 10 gauge barbed wire example. An emphasis is on the thickness, where thickness is crucial. Currently focused on thin, but could also be thick. I'm sure many of you have heard of a 3 cm or 30 millimeter porcelain tile today. 2 cm, 2 millimeter or 20 millimeter porcelain tile. I mean, these are 3/4 of an inch to 1 1/4 inches thick. The process is very similar to what we do with gauge porcelain tile in manufacturing. It's just the powder, if you might, is made thicker. And these ones could be used anywhere from landscaping, just dropping them in your yard for a path, a walkway, if you might. Maybe ballast roofs where they're having to have walk areas on top of a roof. Typically used in pedestal systems without any support. In other words, they put 4 pedestals underneath it and you're walking directly on the porcelain tile. So let's talk a little bit more about gauge porcelain tile and gauge porcelain tile panels / slabs. Why 2 different names? Gauge porcelain tiles are considered less than 1 square meter. There's a variety of tiles out there today in gauge porcelain tile. We all think of these large ones that are 5 foot by 10 or that are 3 foot by 10 foot, etc. But really there's ones out there in gauge porcelain tile that are as thin as planks, 8 inch by 80 some inches. There's some that are 1/2 meter by 1/2 meter. So you're looking at a little less than 20 inches by 20, 20 by 20. Anything larger than 1 meter and larger is considered a gauge porcelain tile panel / slabs. Call it what you'd like, but that's the difference is in the size of it. A little bit more on the gauge porcelain tile panel / slabs standards. Table 4 has within it that it should have a nominal thickness of 5 millimeters to 6.5 millimeters for use on floors and walls, with or without reinforcing mesh. Fairly common to see gauge porcelain tile with this mesh on the back of it. Some of the testing requires absorption and bond strength of this mesh after 7 days after it's been submerged. And as I said, they're also tested with and without the mesh for absorption. Products with thicknesses from 3.5 millimeters to 4.9 millimeters are considered for walls. Certainly you could do thicker than that. 6.5 would be fine for a wall. They're not commonly marketed that way, but we certainly hear enough about and get enough requests for the thicker ones on walls too. Today we're getting requests for 12 millimeter, which is typically used for fabricating, but it's out there as well. The biggest thing that I think we're really trying to stress here with this size is that these sizes are great for walls. You don't see them being recommended for floors and walls. So really we want to stick to floors, 5 millimeter to 6.5. I hope that makes sense. One thing that's unique about the gauge porcelain tile product standard is that it's one of the things within the standard is that it has to be tested with the Robinson floor testing machine. I'm not sure if you've ever seen a Robinson floor testing machine. It's common to the tile industry, and as a matter of fact, this one in the bottom right is our machine. I'm not sure this one. This is typical to what might be a TCNA. Really what happens with the gauge porcelain tile standard, I'm going to step away from gauge porcelain tile and just talk about traditional 3/8 of an inch or 10 millimeter porcelain. So if I took a concrete slab, which this is about a 4-inch concrete slab, on top of that I thin set or use a polymer modified mortar and adhere 12 by 12 porcelain tile on top of it. Then I start these wheels that you see rotate four times with 900 cycles with 100 pounds per wheel, and it gets all the way up to 300 pounds per wheel, and that's a soft rubber wheel. We look for damage. Anytime it's damaged, we stop the test. It goes to the next phase, which is a harder wheel, rubber wheel, if you might. Again, 4 rotations of 900 cycles. The weight on the wheels increasing from 100 to 300 pounds per wheel. The idea being, if I was to go through the final rotations of this, it'll go all the way through 14 cycles, and the last section is with steel wheels. So we're really abusing the system itself, and it constantly rotating and so on. You can imagine it takes a lot of abuse. If I got to an extra heavy rating, and I'll show you a little bit more on extra heavy ratings or service ratings after this. If I got to an extra heavy rating, that would be great. And that's typical what we would anticipate out of porcelain tile and a concrete slab with a good polymer modified mortar. But if I put a 10 millimeter recycled sound rubber membrane in between it, so now I've got a porcelain tile adhered down to the concrete slab with a 10 millimeter or about a 3/8 of an inch thick recycled rubber sound membrane. Is it going to perform as well? No. The odds are very good that that'll break down or break a tile or pop out a grout joint or something will fail, I don't know, midway through the test, anywhere from moderate commercial to light commercial to residential type construction. So the benefit to us as manufacturers of setting materials and so on is we can test assemblies and see how much wear or abuse, if we might anticipate. If I'm anticipating a skywalk, if you might, between the airport and the parking garage, I want to make sure that area can handle a lot of abuse with wheel traffic and so on. I probably want to get it up in the extra heavy range. If I'm doing a commercial kitchen, not even that, just a kitchen in an office setting for tenant finish, I don't need nearly that much abuse, if you might. Just like commercials should be suitable. So I might say, okay, we can have the sound membrane. We got kitchens on every floor of this large commercial office building to take care of the tenants, and I don't want the sound coming through to the tenant below, so I'm going to put a sound membrane in there, and that'll perform well in that use. So we really test assemblies. In the case of gauge porcelain tile, it has to come out with a light commercial testing with gauge porcelain tile used instead of the regular porcelain tile on the top. So the TCNA handbook, you'll see a lot more on service ratings, but give you an idea, cycles 1 through 3 gives you a residential rating, again with up to 300 pounds per wheel. 4 through 6, you get light commercial, and then a moderate commercial, heavy commercial, and extra heavy. And you can kind of get an idea, commercial kitchens and so on, and extra heavies, food plants, dairies, breweries. Really, I mean, they're taking fork truck traffic as well as pallet jacks, heavy carts, a lot of concentration on a small wheel. Just because a assembly may pass extra heavy does not mean the manufacturer wants it used in heavy. I'll come back and talk about that in a little bit more detail. But heavy malls, stores, commercial kitchens, etc. Light institutional work, restaurants as an example, or hospitals for moderate. And then light commercial would be offices and bathrooms and so on in an office complex. And last, foyers as an example of residential. So typically with a gauge porcelain tile, this is the type of damage we see. It doesn't just crack as we typically see with 10 millimeter or 3/8 inch porcelain tile. It actually spalls, if you might, or fractures right there. And the grout joint will typically pop out as well. Light commercial is the minimum requirement for a gauge porcelain tile to say it meets 137.3. Some other tests that are done: minimum breaking strength. How many pounds pressure does it take per foot to actually break the tile? You can see it's suspended on 3 legs. Pressure is applied to the center. Same thing here with modulus of rupture. All right, that's just a quick overview on gauge porcelain tile. Let me talk quickly about the installation standard. Again, this is the installation standard for interiors with the thin set mortar. There are 20 sections to the new installation standard, and I'll assure you some that you've never seen before in ANSI standards. Job site and material handling requirements, we didn't used to have that when it came to really 8x8 or 12x12 tile. But today with tiles 5'3" by 10'6", yes, you need to have a large enough area to be able to work, a large enough area to be able to transport it through there and protect it. We have things like how do you embed the tile in order to get coverage, workmanship, what happens with damage to the tile work, contractor qualifications, all important. So as I said, the ANSI test methods are reaffirmed or revised every 5 years. In 2012, there were some real changes. Revised the 118.1 and 118.4 standard, and then brought out the new 118.15 standard. These new mortar standards and revisions brought out a new test method. The new mortar standards and revision also brought about new mortar standards. So 118.15 is a premium latex modified mortar. I'll get into why we say that in a little bit more detail. This new mortar designations is new to ANSI and very, very important. It can be very beneficial to you in the field. So let me talk about that. Again, when you look at the ANSI standards, this is how it falls. 118.1 is a dry set cement mortar. 118.4 modified dry set cement mortar. 118.11, you'll notice I didn't bring that up in the previous slide. 118.11 is an extension of 118.4. 118.11 is for gauge porcelain, exterior glue plywood only. So you must test with gauge exterior glue plywood, and the test for exterior glue plywood is basically all that's in 118.11 because you have to have already passed all of 118.4. If you have a designation of 118.4, let's say for instance for non-sag, it would say 118.4T. That would be the same thing true of 118.11 if assuming it passed 118.4T. 118.11 is modified or improved modified dry set mortar. 118.15. This is a real improvement to our industry. In the past, you could go out and get a 118.4 mortar, latex modified mortar, that was anything from barely meeting the standard to an outstanding, flexible, well-performing mortar. But there was no differences. And so that's what this standard really kind of set out to do. So think about 118.4, if you might, as the standard dry set mortar, standard performance. 118.15 is established for high performance mortars. It has higher shear strength requirements, but most important, it has a new test called heat aging shear bond test. Let's talk about that because I think that's a real cool thing for you guys to understand. So the heat age shear bond test takes 2x2 porcelain tiles bonded together, offset 1/8 of an inch. The specimen is cured 14 days at basically room temperature between 70 degrees Fahrenheit and 77, followed by 14 days at 158 degrees Fahrenheit. 14 days at 158 degrees Fahrenheit. After all of that, the shear bond must be greater than, I really believe it's 450, but 400 PSI. Well, 450 would be greater than 400 PSI, but I'm pretty sure the standard actually calls for 450. So that's quite a strong mortar. The interesting thing about this type of mortar, because of the temperature fluctuation, you aren't going to just pass this with adding more cement to it. You have to actually make sure that you're really controlling the polymers and the additives to make sure that it can perform this well through these thermal changes. So, as I said, with a high cement ratio, that's not enough to pass it. It really requires a high polymer content to pass this test. Where might you use a 118-15 mortar? Anywhere where freeze-thaw might be a consideration, where flexibility is desired, maybe a lobby on the top floor of a 50th floor of an office building in front of the elevators, where improved bond strength is necessary. So you've got something you believe is difficult to bond to. Could be a porcelain tile. In the case of a, oh gosh, I'm trying to think of a great example. Well, for that matter, it could be a membrane or something like that that's tough to bond to. Where improved shear strength is important, where improved thermal resistance is needed, where heat resistance is important. So, great example, exterior walls where there's freeze-thaw environment, decks and balconies, the installation of large format tiles where significant expansion contraction can be expected, maybe a lot of thermal change, above grade or above ground floors with potential for deflection. ISO designation for deformation could also be very, very important here. I'll get into that in a little bit more detail. So these are some of the test methods for everything from 118.1 to 118.4 to 118.15 mortars. And you'll notice that when you look at some of the strengths here, and I won't go through all of them by any means, but give you an example, shear bond test tile to tile. Here you're looking at 200 PSI for a non-modified dry set mortar, 300 PSI, so 50% higher when it comes to 118.4, 450 PSI when it comes to 118.15. That's an exceptional jump. Again, 50% higher. When it comes to heat aging, it's not done at 118.1. It's not done at 118.4, but I was correct. 450 PSI after 14 days at room temperature, then 14 days at 158 degrees. That's impressive, if you ask me. You'll see a lot of differences as you go through it, from 150 to 200 to 400 PSI, doubling in strength after 28 days. And also 28-day heat aging here with a porcelain tile, that has to be 400 PSI. 28-day freeze-thaw cycling, 118.4, 100 PSI, same requirement for the 118.15 mortar. So you can see a real benefit in the 118.4, 118.15 mortar, I believe. Much higher strengths, good flexibility, allows for thermal expansion contraction much better. All right, so when they added the 118.15 designation for improved modified dry set mortar, they also added mortar designations. So if you had a 118.4, I'm going to keep it real simple. Again, these designations could be added to any of the mortars, but when you have extended open time, 118.4, it might say 118.4E, extended open time. What would be the benefit in you knowing that? Maybe you're working with gauge porcelain tile and you want to make sure that you have plenty of open time because you're going to be spreading 50 square feet on the back of a tile as well as 50 square feet of mortar on the back of the substrate. So you really have to have a lot of open time. An extended open time mortar would be wise to have. 118.4F would be a fast setting mortar. 118.4T, non-sag mortar, and the newest one from last year, 118.4, large and heavy tile mortar, medium bed mortar. So that's new. When it happened to 118.11, again, you have to meet 118.4 and all of it. For it to become a 118.11, it also has to pass the exterior grade plywood test. So 118.11 has very little content to the testing because most of it's in 118.4. It's an extension, if you might, of 118.4, but with the plywood test. So it is still part of it, but. All right, so let's talk about medium bed mortars. Why do we need another mortar designation? Well, because design professionals have the ability to call out the ideal mortar for large format tile as they are typically being installed today. They can specify by reference standard as opposed to having to do it from proprietary specs. So instead of calling out MAPEI's ultralight mortar, they can call out it needs to meet 118.15H. Tile contractors wanting to bid equivalent products, this is very easy to do if you're comparing the mortar designations. A little bit of benefit of the LHT type mortar. It's defined by its performance characteristics. They're looking for non-sag or non-slump characteristics. If I put a heavy stone or tile into the setting material, I do not need it sinking in and oozing up through the grout joint. I need it to sit there and for me to beat it in or work it in, moving it back and forth and get it bedded properly to even out, if you might, to the tiles next to it. We're looking for less shrinkage at thicker depths. So this material, after beat in, after it's been notched, tile installed, it's been flattened down or beat in. It can go as thin as 3/32. It can go as thick as a 1/2 inch. So standard mortars, ones that are not large and heavy tile mortars, typically are 3/32 to 1/4 inch, to kind of give you a comparative. So you can go twice as deep with this. To provide better coverage for large tiles with some warpage, right? Today we're dealing with plank tiles. Again, they're up to 6 feet long. And in the center, you might have some warpage, or for that matter, not common, fairly common to see 2 foot by 4 foot tile today, for goodness sakes. A little bit of warpage in a 4 foot length, that's quite a bit, it can be sticking up. So this is if we don't get the proper amount of mortar underneath it, that tile is going to be a void right there at the highest point. We want to make sure it's properly covered with mortar underneath it. Both of these characteristics really help with a flatter floor and less potential for unacceptable lippage. So when it comes to the test standard for this material, it actually takes a tile or stone that it weighs a certain amount. I believe it's greater than 5 pounds per square foot. It is set even, flat. It has to have virtually no lippage. And then after 28 days, it's measured again to make sure that the lippage doesn't exceed the lippage requirements within the ANSI standard. What was wrong with medium bed? That's what we called it forever. Where'd LHT or large and heavy tile mortar come from? Well, what started happening is contractors started getting asked to do, instead of properly preparing the substrate, general contractors would tell the tile contractor, just go out there and do a medium bed method. Just build up the mortar, make it work. Not a good idea. There's a lot of potential for shrinkage and other issues with this. They were actually starting to see from architects standards that said medium bed method. So for a traditional mud bed, we're going to have 1.25 inch minimum to up to 2 inches recessed concrete slab. Then we're going to have tile, setting material, mortar bed. You know, we're going to be 1.5 inches roughly with the tile and setting material to meet that recessed slab. We were finding recessed slabs out there that were 1/2 inch, 3/4 inch. Basically, they weren't done correctly, and we're being asked to do that with just a thick bedding and mortar. That's not its intention. The medium bed mortar method was used commonly to prep for bad substrates. And there really was a lot of abuse of the term medium bed, so the industry just felt it was best to just get it out of our vocabulary. According to the TCNA handbook in 2020, it still says LHT, or formerly medium bed mortar, is a thin set bonding mortar for ceramic and stone tile formulated by the manufacturer as to minimize slump and facilitate a thicker bond coat, as compared to typical dry set mortars, basically. Again, in the TCNA handbook in 2020, it says LHT, formerly medium bed mortar, is declared as such by its manufacturer based on its characteristics. There are no ANSI or ISO standards specific to this type of mortar. That is no longer correct. Today, we have the LHT mortar, which has the H designation at the end of the 118.1, 118.4, possibly 118.11 or 118.15 mortar. And that is to recognize it as being a large and heavy tile mortar, or formerly LHT mortar. It goes on to talk about the benefit of the LHT mortar being able to support a heavier tile, being able to deal with large format tiles in order to get enough bonding material in there to get mortar coverage in case of warpage or anything like that. And the same thing here, talking about warpage or regularity of the tile. And for 118.1, 137.1, if you want to get into the specifics about warpage, there are different grades within the case of porcelain tile, from calibrated to rectified and so on, and rectified being the tighter of the two standards. Look at the 137.1 standard. To the specifier, the TCNA handbook says the LHT mortar is not intended for chewing or leveling the substrates or to correct the work of others. Substrate variation exceeds allowances. LHT mortar cannot be used to remedy such because the application would exceed the limitations of the mortar. LHT is intended to be used to install tile per 108.5 and the installation standard for ceramic tile by a thin bed method. Really what we're trying to get at there is if the substrate needs repair, repair it. And you should be paid for it. The installer should be properly prepared to prepare the substrate just as the rest of the other flooring industries are. The wood flooring industry, the resilient flooring industry, they don't even think twice about prepping a floor. They just go in there and do it before they do their project. To the specifier, again, this continues. Accordingly, LHT is a product, not an installation method. Project plans or specifications that call for setting by a medium bed mortar method or large and heavy method that call for the use of a bonding mortar to level, flatten, or fill substrates or create slopes or transitions between finished floors do not conform to the industry standards. So again, where might you use a large and heavy tile mortar? LHT or medium bed mortars have been around for many, many years and very, very popular. They support thick and heavy units. Great example of that could be this large thick tile that you see here, or in many cases, a slate. So if you got an ungauged slate, which used to be very popular years ago, it wouldn't be uncommon to pick up an 18 by 18 inch gauge ungauged slate, and in one end of it be 3/8 of an inch in thickness, the other end of that tile 3/4 of an inch in thickness. The large and heavy tile mortar would help accommodate for those irregularities or take care of that thickness differences. So accommodate for thickness variations and box read method. Box read method's really probably the best way to explain that is if you got different thicknesses of tile, and I'll tell you that's another bit of a nightmare to the installer today, is we get different thicknesses that, different tiles for that matter, different manufacturers, different thicknesses that are being designed together in a pattern on a floor. That's a real nightmare. If you have one that's 3/8 of an inch and one that's closer to a 1/2 inch, that's very, very difficult. That means ideally the best way to do that would be to handle it either through a box read method, or for that matter, you put a mortar board on a mortar stand, cut a hole in the middle. Around the outside of that stand, you cut 2x2 lumber. Let's say it is at the thickest a 1/2 inch in thickness. I lay the face of that tile down. I want to have 1/8 of an inch of mortar on top of that. So I cut my 2x2 lumber at 5/8 of an inch in thickness. Every tile that I lay down in the face of that mortar board, if you might, I screed off the mortar. It'll always come out 5/8 of an inch thick, whether I pick up a 1/2 inch thick one or a 3/8 inch thick one. And then I set it to the floor, to the notches on the floor. So that's a box screed method, and another great example of use of LHT mortar. Why large and heavy tile mortar? Warped tiles, reduced potential of lippage. Large format tiles where one edge is greater than 15 inches. Heavy tiles, ones weighing 5 pounds or greater. The ability to adjust imperfections in tile or stone because of a thicker bedding. And the specialty use like saltillo tile, talavera tile, we saw for years, with very irregular backings to make sure that they get good coverage. All right, another characteristic about LHT mortars and the T rating is typically the Thixotropic. And what does Thixotropic mean is these mortars, while they're applied thick, they'll hold the notch just fantastic. And when you go to move the tile or agitate it, move it back and forth, you create shear and that material starts to flow a little bit, increasing your coverage. What does Thixotropic really mean to you that don't understand what I just said? Well, you pick up a ketchup bottle, you pick it up, put it upside down, nothing comes out. But if you shake it or hit it on the bottom, you create shear and ketchup flows out. So the same thing is true here. We notch this out. It holds the ridges very, very great at a thicker depth. Layer a tile into it, push it back and forth or create shear, and that material increases its coverage just by the Thixotropic characteristics of the mortar. Hope that makes sense. Some of the problems with not using the proper mortar or LHT type mortar is, again, it really should be used with tiles with one edge greater than 15 inches. All substrate preparation with those types of tiles should be within an 1/8 of an inch and 10 feet and should be done previous to installing the tile. No more than a 1/16 of an inch and 2 feet from the required plane. Truing with just thin set can lead to shrinkage issues and loss of bond. Honestly, this is a project that I was on in Atlanta with a tile setter that had formerly been a linebacker for the Atlanta Falcons, got into the tile industry after he was no longer with the Falcons. You'll notice that these joints are nice and tight. These joints are opened up. They were all set tight. He came back later and shrinkage had caused this. It was on the top of a fabric sound membrane. And so it allowed for the shrinkage. The material was applied about 1.5 inches thick in order for them to get it all flat. It was a standard mortar. That mortar shrank. When it shrank, they came back the next day and the grout joints were all over the place, all kinds of inconsistencies in joint size, and the owners were not happy. So needless to say, I told this gentleman that he needed to get some tools out of his truck. We went down to the 20th floor to his truck, got him down there and said, look, this is an issue with your application. And you need to get back up there and tell the owners some of the issues and why this shrinkage occurred. And I'll give you all the materials you need to work this out. And so this came out to be very amiable. And trust me, I did not want to make Matt a former linebacker for the Atlanta Falcons. Still a friend today. Let's talk about ANSI, ISO, because they're both related. ISO is the international standard throughout the world and commonly used throughout the world. ISO 13007 for ceramic tile as well as installation materials. It's an independent, non-government international standards organization with membership of 162 national standard bodies like ANSI. It's got delegates from 50 different countries, meets a couple times a year. And again, still done through voluntary consensus basis. Why does it matter? Because ISO created the recognized way of identifying mortars and the mortar designation that we talk about today in ANSI. Give you an example with how they do it is they do it very simple. They've got 3 different types of mortars by chemical nature. One is cement or cementitious. D is dispersion, like a mastic. C is resin reaction, epoxies and urethanes. And then it's either rated with a 1 or a 2. 1 normal, 2 improved. C2 is an improved cementitious mortar. Very simple. This gives you a better example of looking at it in the mortars. And in addition to that, they have the designations we talked about in ANSI, except there's some new ones here. I want to point out that there is one for deformation. We do not have that in ANSI at this time. So flexibility S1 being it's deformable, S2 being highly deformable or highly flexible. P1 is for plywood adhesion, P2, improved plywood adhesion. Very, very important. So ANSI has these in mortars, but they do not have these 4. In dispersion mastics, if you might, we've got, again, D1, D2 for normal versus improved, accelerated drying, slip resistance, and extended open time are characteristics they like in that mortar. For reaction resin, again, R1, R2, and slip resistance, R2T would be a common one for non-sag improved reaction resin urethane, like our Planacrete W. All right, one big difference between ANSI and ISO is in ISO, almost all the tests are done through tinsel or tinsel pulls. And this is what you see here is our heron is put on top of the 2x2 epoxy plates are glued to tile samples, or in this case, yeah, I think they're stone. So you see, no, I'm sorry, 2x2 porcelain tile there, and then you see the plate, steel plate that is epoxied to the tile. Then the heron's applied to that, and it's pulled straight up. And tinsel is what we measure. Very different. In ANSI, we measure shear. So as I said, you got tile to tile, face to face, offset 1/8 of an inch, and then pressure is applied to both edges, and it's actually sheared off. Entirely different type of test. However, in the tile industry, in ANSI, it's not uncommon to see tinsel as well. It's commonly done with improved or open time tests, and that's what these are. So in the case of extended open time, we adhere tile down at different timing increments, and then come back later and break them free. At one point, the mortar starts to skim over and doesn't have the best bond. As you can see here, it's barely bonded and then hardly bonded here at 30 minutes. So with extended open time, you're looking at after 30 minutes. Typical open times not extended are within 20 to 30. So that's what gives you the E designation, is better open time. As I said, one place I'd really want to consider extended open time would be difficult installations where you're trying to manipulate a lot of things. Could be a pool, could be curves in a pool, could be curves in a seat like this. You're just trying to make sure that all the intricate pieces are put together right. Gauge porcelain tile where you're spreading out a lot of mortar in 2 areas. Transverse deformation. Again, this is a flexibility test. We take the polymer itself, a sheet of the polymer, and apply pressure to the center and see at what point it actually breaks. S1 for deformable adhesives are allowed to deflect greater than 2.5 millimeters or less than 5 millimeters. Highly deformable is greater than 5 millimeters. So the polymer is allowed to deflect quite a bit by itself. This is an example of one of those polymer sheets that are put in that press. There's dry latex polymers and there's liquid latex polymers. Typically the liquid does a lot better job of allowing for the flexibility, allowing for more deformation. And you'll see that in the in the ISO standards. Where would you want one that allows for deformation? Well, maybe in a mall where you've got the second floors to flex quite a bit with traffic. Same thing true of the third area. Slab on grade? No, not so much. It's not quite as critical, right? So areas where you're anticipating a lot of movement. P1 is normal plywood strength, and P2 for exterior grade plywood with higher strengths, going up to 145 PSI tensile strength to the plywood, as opposed to half that for P1. Mastics, same thing. In this case, we're looking for normal strengths, 145 PSI. And D2, we're looking at much higher strengths, 145 PSI with elevated temperatures and water immersion. So in this case, characteristics are a little bit better. D1, normal installations, anywhere, a dry area, interior areas, powder rooms in a bathroom would be a great example. Commercial and residential walls. D2, I'd use it in a wet area. To me, that makes complete sense. So intermittent wet areas, bathroom showers, etc. Reaction resin, Like our urethanes, it's the best example I can think of in the industry, not to mention epoxies. They're reaction resin, 1 normal, 2 improved, and T for slip resistance. So these epoxies and urethanes are used over steel, moisture sensitive stones, chemically resistant applications like a dairy or brewery, really difficult to bond substrates like steel. We do a lot on ships with epoxy type adhesives and urethanes for that matter. One is a little bit more brittle, one is a little bit more flexible. The urethane can be more flexible. Again, R2, where might you use that? Moisture sensitive stones, chemical resistant applications, difficult to bond steel, industrial plants, and where you got a lot of thermal shock, a lot of high expansion, contraction, and so on. Grouts, we have the same thing. CG for cement grouts and RG for reaction resin grouts. CG1 is normal, CG2 is improved, and fast setting, high abrasion resistance, and reduced water absorption are some of the characteristics for a grout. Reaction resin grouts, high performance characteristics are better than a cementitious grout. C1 being normal cementitious grouts. Installation is not exposed to extreme temperature changes, moisture, or anything like that. Residential commercial applications be suitable for C1. Other areas where you might use a C2, areas where ceramic or porcelain installations, because of the low absorption of the porcelain. Areas subject to a lot of moisture exposure, thermal shock, high traffic areas, interior and exterior commercial and industrial type applications. And again, those designations are fast setting, high abrasion resistance, will take a lot of abuse, high abrasion, and reduced water absorption. Again, other areas, exposure in areas of higher temperatures up to 112 degrees Fahrenheit, food processing areas, chemical resistance, dairies, chemical plants, and food processing. Great examples of use of epoxies. So standards, why are they important? Well, they establish a quality level for established products that we know have been successful in the United States. Generally, it takes use of these products for a while before we can really write a standard on them. And uncoupling being a great example, Gage porcelain tile also took a lot of experience and use in installations. To build the confidence in a new tile or product category, like Gage porcelain tile, to establish a standard that the specifiers can use to that's performance-based as a reference standard, as opposed to, again, using proprietary standards. To the architect, it's beneficial because they know they're getting the material specific for the type of project they're trying to achieve. They're able to generate generic reference standards and yet set a level of quality. 118.4 mortar versus 118.15. They can call it a 118.15 on an exterior installation, make sure they're getting the right type of mortar. This allows for a competitive product at bid for the contractor, and they should get a more competitive bid. To the tile contractor, it really makes evening the field a lot easier, understanding what the different mortars between different manufacturers do. You can easily compare the differences in manufacturers' products for performance, can really get a product tailored for the installation, and really offer more confidence in the installation, allowing for a better warranty. Where would we be without standards? Well, we're not doing this anymore. That is an old tinsel bond test. As you can imagine, the heron works a lot better, especially on this gentleman's rear end when it does finally give. In summary, tile industry standards help us establish an even playing field for all involved. Selecting the proper mortar for your project using ISO or ANSI designations can really dial in the performance of your mortar for your specific need. Specify the grout based on performance as well. As our industry continues to be innovative, we must keep up with industry standards to make it understandable by you guys and make sure you're getting the proper products in the field. Thank you.
And thank you, Jim. And we have exceeded our hour. So if there are any questions, again, please either email them to jimwhitfield@mapei.com, or you can always, again, send them to mapeidigital@mapei.com. And thank you for joining us, and we look forward to seeing you at our next webinar next week. Thanks again. This concludes today's presentation.
Thank you.